Hi, I'm JD, and what we're going to be doing today is a hypothesis test for two proportions. Let me read the problem to you. A survey found that 81% of the men surveyed preferred online instruction to on-campus instruction, and 73% of the women preferred online instruction to on-campus instruction. There was 100 in each sample. At alpha equaling 0.05, and that's its significance level, test the claim that there is a difference in the proportion of men and the proportion of women preferring online instruction to on-campus instruction. So pause the video and see if you can try to do this one on your own. Alright, step one is always the same. Step one is you're going to list out your hypothesis and identify the claim. So first look at the claim, because that will tell you what to do for your hypothesis. So test the claim that there is a difference in the proportion of the men and the proportion of the women. So since it's saying a difference, and it doesn't matter if it's greater or less than, then it would be not equal to. So P1 minus P2 does not equal 0. And your null hypothesis always includes equals. So it would be P1 minus P2 equals 0. Alright, step two is you want to find your critical values and your critical region or your rejection region. So normally I draw it out. It's going to look something like this. And I have a little bell shape. This is going to be z-scores. And since it's not equal to, it's going to be two tails. Now, since your alpha is 0.05, that means this area is half of that, so that would be 0.025, and then over here, 0.025. Now, what you can do for common ones, you can make a table yourself, but you might need to look it up in the standard normal distribution table. You have an alpha equaling 0.0, well, at one end, 0.025. And notice I have the negatives. And look at the bottom. Always look at the picture. Right here. So, I'm going to look up 0.025. And look, it's exactly that. So that would be negative 1.9, and the column is 6.06. So it would be negative 1.96. Now, if that's the negative, then the positive, it's the same thing because it's symmetrical. Now, step 3 is you want to calculate your test statistic. Here for two proportions, it's somewhat complicated. It's the observed, so P1 minus P2 hat minus the hypothesized proportion, so it would be P1 minus P2 parentheses. Now underneath you have the square root of P bar times Q bar parentheses 1 over n1 plus 1 over n2. And p bar equals x1 plus x2 over n1 plus n2, and q bar is 1 minus that, 1 minus p bar, and then p hat is the proportion of the sample. Here it's x1, n1, and then p2 hat would be x2, n2. Here you have the percentages, and I would just write them as decimals, so 0.81 for the first one, and then for the second one 0.73. And then for p bar, underneath it's 100 plus 100. Now to find the number of success, here it's really easy to calculate because it's just going to be, it's 81%, so it would be 81. But how do you calculate that? Convert it to a decimal and then multiply it by the number of the sample, or the total in the sample. So it would be 0.81 times 100, which is just 81. And you do the same thing with the other guy. There would be 73. And then you calculate that. Now I'm using a scientific calculator for both, so for both my numerator and denominator I'm going to need parentheses. So it would be 81 parentheses 81 plus 73 close parentheses divided by parentheses 100 plus 100 close parentheses equals 0.77, and q bar is 1 minus that, so 1 minus 0.77, and that gives me 0.23. So I have all my calculations, plug everything in. So my p hat 1 is 0.81 minus 0.73 parentheses minus p1 minus p2 is 0, because that's what the null hypothesis is. p1 minus p2 is 0. So that all cancels out, and then you have your p bar, which is 0.77 times 0.23 parentheses 1 over 100 plus 1 over 100. Clear, you're going to type all this in. So I'm going to type it on a scientific calculator, and you might not be able to see it. It might be a little hard to see, but I'm going to tell you what I'm typing in as I go, because you want to put parentheses around your numerator, and then whatever's in your denominator, when you're dealing with a square root, especially with a scientific calculator, it's going to open up the parentheses, and so you need to close parentheses over here. And the square root will act like a grouping symbol for the denominator, so you don't need to put the square root in parentheses as well. So parentheses. Now it's not necessary for me to have these right here, so it'd be parentheses 0.81 minus 0.73 minus 0, close parentheses, divided by the square root. The square root in the scientific calculator automatically opens up a parenthesis. So 0.77 times 0.23 parentheses, and now I type this in, 1 divided by 100 plus 1 divided by 100. I have to close the parentheses for this and then close the parentheses for the square root. After I do that, just push enter and I get approximately 1.34. And usually how I round it is whatever my critical values are, I kind of match those decimals. So this is 1.34, which falls here, slightly under one of the critical values. Since it does not fall in the rejection region, I do not reject the null hypothesis. So step 4, do not reject the null hypothesis. Step 5 is your conclusion. Now let me make sure you have all this down. Now write the conclusion right here. So step 5 is the conclusion. Now the conclusion is based upon where your claim is at. Remember, my claim is the alternative hypothesis. That's where my claim is at. Which means that it's in reference to supporting it. But since I'm not rejecting the null hypothesis, that means I'm not accepting this claim. So since I'm not accepting this claim, there is not enough evidence to support the claim that, and now at this stage, just restate the claim. You don't have to use the exact words, but similar. So I'm just going to use the exact words, it's just easier that way. That there is a difference in the proportion of men and the proportion of women preferring online instruction to on-campus instruction. And that's it.